Okay, so our new stuff is now we're going to graph, or we're going to solve systems of three equations with three variables. So it's still linear. A third equation just introduces a third dimension to the, or a third variable just introduces a third dimension to your graph. So 3 points make a plane, right? We remember that. Three non-collinear points make a plane. So these are all planes. Z equals 2x minus 3y plus 2, z equals 4x minus y minus 2, and z equals x plus y minus 3 are three different planes, and they're going to intersect in a point. So if you remember from geometry, two planes intersect in a line, right? There's going to be a whole line where they intersect. But a third plane introduced into that that's not the same plane is going to intersect in a point. So I have it graphed on a grapher right here. Hold on. Okay, so these are my three equations. These are the three planes. They're different colors. I can kind of move this around and you can see, you can look at any two, like if you look at the green and the purple right there, you can see that line where they intersect right here. But if I tilt it, kind of, you can look right here. I don't know if you can see my pointer. Whoops. But you can look right here and you can see there's that point where the three different planes intersect. So you can kind of cover that up. You can't even see that orange plane anymore, but you can see the purple and the green make a line. But now if we tilt it, you can see right here where they make a point where they intersect. I believe it's right there. Yeah. So we're still going to have a point for our solution unless other things happen, and we'll talk about those in a minute. So this is a system with three variables in triangular form. This is called triangular form. It looks like it makes a triangle, right? So here's our triangular form. It makes like a triangle right there, kind of. And if you can get it in triangular form, it's going to be really easy to solve because you can just use back substitution, plug things in, right? So this one we have in triangular form, so we're just going to solve it. So if you know that z equals 3, plug it in to the next equation. So you have y plus 2 times 3 equals 5, y plus 6 equals 5, y equals -1. So now you know your z and your y, and you can plug those in. It's called back substitution because you're going backwards to find all your answers. So you can plug those in. X minus 2 times -1 minus 3 equals 1. So x plus, whoa, sorry. There. So x plus 2 minus 3 equals 1. X minus 1 equals 1. X equals 0. So our solution is still a point. It's a 3D point now. Our solution is 0, -1, oops, 3. You write it in alphabetical order, or you write it in the order that the letters were given to you. So you're given the order X, Y, Z, so your answer is going to be X, Y, Z. So if you decide to write it in a different order, your answer is going to be wrong. So make sure you write it in the correct order. Okay, so in a future chapter, chapter 11, next, we will learn techniques for systematically converting systems of equations into triangular form or into forms that are even easier to solve. So that's when we do matrices, and we'll do that with the matrices. But for now, we're going to use just other techniques that's kind of building on that. So you can combine two different sets of equations, eliminating the same variable. That's what you do with elimination, right? You're trying to eliminate a variable. Solve the resulting two unknowns using any technique. I use elimination all the time, and then use the solution found in step 2 and one of the original equations to find the variable. So I'm gonna do elimination every time. If you choose to do something else, you can, but elimination is really the most methodical way to do it, and you can easily find if you made mistakes or not. If you decide to use substitution, sometimes you end up substituting into the wrong equation because you're using 3 equations, and that can make mistakes. But you can do it how you want, but I will always do elimination, and I'm going to set it up really the same way every time. So first I'm going to label these as row 1, row 2, row 3. And our goal is to eliminate one of the variables. So you can choose which variable looks the easiest to eliminate. And really, any of them are good choices here. So I'm going to choose to eliminate the x's on this one. You can choose the y's or the z's. It doesn't matter which one you eliminate, just choose one of them. So if I want to eliminate the x's, I notice that row 3 has a negative x. So I could multiply row 3 by something and cancel out the x's in row 2 and cancel out the x's in row 1. So you're going to do this as two different steps. So first you're going to combine any two of your equations to eliminate a variable. So I'm going to combine row 1, and I'm going to write what I'm doing so that I can go back and figure out what I did. And I'm going to add that to 4 times row 3. The reason why I write them like this and I do that is because when we do matrices, this is kind of what you're going to have to do. So I'm getting you used to using the right methods or the right techniques at the beginning. So I have row 1, which is 4x minus 3y plus z equals negative 10. And then for row 3 is negative 4x plus 8y minus 20z equals 68. I think that's right. Add them together. The x's cancel. You have 5y minus 19z equals 58. All right, so I've used row 1 and row 3 to eliminate the x's. Now I have to use row 2, and I can use either one. I can use 1 or 3 again, but I have to use row 2 this time. So I need to eliminate the x's from row 2. So I'm going to use row 2 and row 3. So I'm going to say row 2 plus 2 row 3 and eliminate the x's again. So I have 2x plus y plus 3z equals 0 and negative 2x plus 4y minus 10z equals 34. Combine those, the x's are going to cancel again, and I get 5y minus 7z equals 34. So now I have two new equations, right? I have new equation 1 and new equation 2. And now it's just a system of equations with two variables, right? Two equations, two variables. So if I call this one row 1 now, and this one my new row 2, and I need to eliminate another variable. So this is what I was talking about, that I use elimination every time. So I'm going to use elimination in step 1, and then I'm going to use elimination in step 2. So the y's obviously are the easiest ones to eliminate. So I'm going to say row 1 minus row 2. So these are my new ones, right? And that's going to give me 5y minus 19z equals 58 minus 5y plus 7z equals negative 34. So I went ahead and just changed all the signs, and now I can add, and that's going to be easier to remember instead of having to distribute the negative sign to all of them. Like I did that now, so now I just add. So 5y is gone, and I get negative 12z equals, hopefully that's, 24. So z equals negative 2. Okay, so I've solved for one of them. Now you take that and you plug it into either of your second tier. You know, this is like, I'm back substituting, right? So I'm going to substitute that back into one of those. It doesn't matter which one you choose. I'm going to choose the right one, the green one, because the numbers are easier. So 5y minus 7 times negative 2 equals 34. So I have 5y plus 14 equals 34. 5y equals 20, y equals 4. So I have y, and now you go back up to the top and you choose your first tier equations, right, your original ones, and you plug those in to get your x. So you plug the y and the z into any one of those three to get your x. I think I'm going to choose row 2. It's the one I like better. So 2x plus y plus 3z. So 2x, here, let's change colors. 2x plus 4 plus 3 times negative 2 equals 0. So 2x plus 4 minus 6 equals 0. 2x minus 2 equals 0. 2x equals 2. X equals 1. So my solution, 1, 4, negative 2. You can check it. So to check it, you just you have to plug that into all three of your equations. So 1, 4, negative 2 into your 3 original equations and make sure your answer is correct. We haven't done anything to cause extraneous solutions. We've just done elimination, so you shouldn't have any, but if you want to check it, you can. Okay, I'm going to go ahead and stop this video. We have one more example to do, but I just want to make sure I have time and it doesn't cut off. So I'm going to stop this one and then do one more example on the next one.